Hey guys, and welcome to part 2 of my IBM 5170 restoration video. If you haven't seen part 1, I highly recommend that you do. I'll put a card up in here and a link into the description. But in short, we managed to get the PC cleaned up a little bit and get it up and running again, showing an IBM personal computer basic screen. But we're not there yet. The goal of this video is to get it into a state where we have most of the peripherals like the floppy drive and the hard drive up and running. We're going to be doing some configuration of the machine in this video, look at the various expansion cards and the state that they are in, do some cleanup on those expansion cards, do some diagnostics because some of the expansion cards are not working, and do some fixes where needed. We're also going to give the motherboard a good wash as it is pretty dirty. Now, although I removed most of the dust from the motherboard, it still requires a thorough cleaning. So for that, I am going to be removing the memory chips, the CPU, and the BIOS chips. Because the last thing you want is to have water getting stuck under these components and not being able to dry properly. Now the 286 CPU sits in this 68-pin PGA 68 socket, and the CPU itself is also in a 68-pin PGA package. So here you can see the 68 pins on the back of the CPU, and this is the 286 manufactured by IBM running at 8 MHz. I'm also going to be removing the two BIOS chips from their sockets. So this is a later version of the 5170 BIOS, which also supports 1.44 megabyte floppy drives. And you can already see just how dirty it gets inside these sockets. So we'll need to do the same for the memory chips on the main board. So there are two memory banks here with a total of 512 kilobytes of RAM on board, meaning that each chip carries 32 kilobytes of RAM. And just look at the sockets here, just how filthy things get. So it's good that we remove them so that they can get a good wash now. Now to clean the motherboard, I'm going to be using my dishwasher. So please don't tell my wife about this. I've emptied it, obviously. So I'm just going to be putting the main board or motherboard. I've gotten some comments that people don't normally say main board and that you should always say motherboard. Although I have seen the term used in motherboard documentation, so yeah, I'm not really sure about that. So we're just going to be putting it in the dishwasher, not using a product, just water, and after about half an hour, 40 minutes, it should be ready. So let's take a look. It's already looking shinier than it did before. It's still a little bit wet, obviously, so after washing this, it needs to have sufficient drying time. You can put it outside and let it just dry in open air. But then you need to have like a sunny day and you need to be able to put it somewhere outside for a long period of time. Luckily, it was a bit of a sunny day, so I was able to put it outside for a couple of hours, but that's definitely not enough because water will keep creeping out of these sockets and connectors, so you need to make sure that it's absolutely 100% dry before you turn it on again. And that's exactly what I did. So I left the board drying for a little bit over 2 days, I think, so I'm pretty sure that everything has dried up now. I reinserted the CPU, the memory chips on the motherboard, as well as the two BIOS chips. And then we can insert the motherboard into the case again. And man, this thing looks so much better now. I mean, combined with the case, which is also cleaned up a little bit more. Just look at how the main board used to look like, even if most of the dust had already been removed. Putting it in a dishwasher is definitely a good thing in terms of cleaning. So I'll add a video card here, and now the moment of truth. Will the main board still work after the dishwasher and the reinsertion of the components? So let's take a look. And let's turn on the computer. And it is posting, so that is already a very good sign. Now, for those of you that watched the first part of this video, you will know that the PC failed to start with the original MFM controller card. Now, given the state of this computer and its expansion cards, I thought the next order of business would be to use a working MFM controller card from a working computer like this IBM PC XT286, which also has a 16-bit ISA MFM controller, and see if the PC would work with that one. Now, the first thing we want to do is to start the computer using this floppy disk, which contains MS-DOS and the G setup program that we will use to configure the PC. Now, take into account that this PC doesn't have a battery, so all of the CMOS settings have been lost. So we need to reconfigure the machine using the G setup program, which is on this disk. But first things first, let's see if it will boot off of the floppy disk, which shouldn't be any problem. Indeed, it isn't. So, and we have MS-DOS loaded. Now it's time to run the G setup program, which is a utility that allows you to change the CMOS settings. It indicates that it doesn't have any power, so all the settings have been lost. But here we can set up the different CMOS parameters. For example, we can set the time, we can set the date. The floppy disk A is marked as undefined, but by default it will always be able to boot from a 1.2 megabyte 5¼ floppy drive, as we have here in this computer. But we'll go ahead and define the drive correctly, so we'll pick option number 3. Now, to configure the hard disk, we get a list of predefined hard disk types. Our Seagate is a 32 megabyte MFM hard drive that corresponds to hard disk type 8. So we'll go ahead and select that. And for the base memory size, we'll select 512 because we have 512 kilobyte of RAM installed on the main board. So with all of the options set, we can hit escape, hit enter to reboot the system. So it should first initialize the floppy drive, which it is doing here. I think it found the hard drive because there are no errors. And here we can definitely notice some hard drive activity, and the PC is indeed starting off the 30 megabyte Seagate hard drive, which is excellent. So that means that the hard drive can already boot, which is a good thing. We'll obviously need to reformat the hard drive and check it for errors, but we'll do that at a later stage. But for now, I'm pretty happy with the fact that we are able to boot from it. So let's see what kind of applications we have here. Obviously, we have the mandatory banner application installed. So that's loading fine. So let's take a quick look on what we have here. It is MS-DOS version 6.0. We have 512 kilobytes of conventional memory. Again, this is in French because the PC came from France and it's still the original operating system and software which is on there. Let's do a check disk, and check disk reports the hard drive as being a 50 megabyte hard drive, which is a bit odd because this is a 32 megabyte MFM hard drive. So obviously the user has installed some kind of disk doubler like double space. And yeah, as you can see, check disk is also launching the double space examiner, which will check for errors on the C drive and hopefully will come up empty, as is the case, which is good. So I took a quick look to see what was on the hard drive. I normally don't really like poking into other people's stuff, but it's always nice to see on these old computers what kind of games are installed or what kind of applications. I mean, I doubt that there is any sensitive personal information on it, but obviously you need to take some caution with this. But here it's just for academic purposes to see the type of applications which are installed, what was being used at the time. So here we can see a rapid file, which is a database application. And it also had PC Tools Deluxe installed. So here we can get a overview of the PC, which is the IBM PC AT, a 286 CPU, 512 kilobytes of RAM, and a 33 megabyte hard drive. Now, G-Setup isn't the only way to set up your IBM 5170. In fact, the official way is to use the IBM AT5170 Advanced Diagnostic disk, which is a bootable disk provided by IBM to set up your PC. And when you start the system with this floppy, you get the Advanced Diagnostics menu. And this is kind of a more interactive way of configuring your system using kind of a dialogue. So it starts by asking what the date is. It will then ask for the time. Next, it wants to know what kind of disk drives you have in your system, how many fixed disks are installed, what type of fixed disk is installed. So it's pretty much the same as what you would enter in the G-Setup program, but it does so in more of a dialogue kind of way. So it also asks us for the memory size. And at the end, we get a nice summary of the options that we have selected. And if these are okay, we hit yes, and then we can enter, and the system will reboot much like G-Setup does at the end. And for those who are interested, there is a third way of setting up your IBM PC, and that is using GWBasic. I will put up a card here in the video because actually in the first video I ever did for this channel, I used this method to set up my IBM PC XT286. So you can actually key in lots of basic commands in the IBM Computer Basic prompt, which allows you to set up your computer, much like G-Setup does or the IBM Diagnostic disks. It's a bit cumbersome to say the least, but imagine a case where you didn't have any floppies. This would be the only way to set up your PC. But now back to our original MFM controller card, which was in this PC. So this is the original fixed disk floppy diskette expansion card, which was found in the IBM 5170. This is the first revision of this card. And if we take a closer look, a common failure of these cards are, of course, the capacitors, which can be found here below, C45 and C46. I am going to be doing some measurements on them, but they will probably need to be replaced. So I'm going to be using my ESR meter, and the first capacitor gave us an in-circuit leaky message, but a good ESR value. The second one did give us a capacitance of 23 microfarad. This is a 22 microfarad capacitor, but a reasonably high ESR value. So I am going to be replacing these 22 microfarad capacitors. The original capacitors were of the axial type because the two through holes for these capacitors are pretty far apart. So with a normal type capacitor, you cannot bridge that distance using the two legs. So I'll need to be a little bit creative here. But I'm going to be clipping off one leg of this axial capacitor because I do want to do some measurements again out of circuit, because even although these ESR meters claim that they can do in-circuit testing, it's always better to test a component out of circuit just to make sure that there isn't any interference with other components. So I'm going to be doing that now. So here I have my ESR meter again. So let's check the two capacitors again. So we had one which was in-circuit leaky and one with a high ESR. And what we see now is that the first one gives us a 22 microfarad capacitance with a low ESR value, and the second one, same thing. So 23 microfarad capacitors, but again a low ESR meeting. So this just goes to show that, you know, it's not always an ideal solution when you need to do in-circuit testing. But I'm going to be replacing the capacitors, and because I don't have any axial capacitors, I am going to be extend the legs of my standard tantalum capacitor by using an additional piece of wire here. So this should fit. It's not ideal. I will be ordering some axial ones, but I didn't have them at hand today. So this is a temporary fix, but I am very anxious to see if the computer will boot now with this card with these new capacitors installed. So let's go ahead and insert the card into the PC. Attach the ribbon cables from the hard drive and the floppy drive, and see if the machine will boot. And we already have sound, so that is good. So there is no more short in the PC. The PC is booting. It's initializing the floppy drive, but it's making a clicky noise and it doesn't seem to want to read the actual floppy disk which is installed, which is a bit of a bummer. So we're back with our MFM controller card, and let's zoom in on this chip here, which is the chip which is responsible for the interactions with the floppy drive. And if we flip the card around, we see that there is some corrosion on the pins here on the back. So this is a result of the battery leakage. Potentially there are some damaged traces here, or we need to reflow some of the pins here. So let's take a closer look. So I'm just going to be cleaning this area up a little bit with some vinegar, and then use some isopropyl alcohol to clean everything up so that we can get rid of most of the corrosion, and we can take a more closer look at the actual traces. And after a visual inspection, something caught my eye, which was this pin here and this trace, or this area of the trace here, which does appear to be somewhat damaged. Now, what I typically do in this case is I follow the trace from the pin and see where it actually leads us. So let's take a look. It goes over here and then it finally ends up here on this pin. So we should have continuity there. Now, following these traces can be a bit challenging because it's kind of a treasure hunt. For example, here there was a trace that I also wanted to check, which was hidden under this sticker and then continues on the other side of the board. But in this case, it was pretty obvious to follow. So let's take our multimeter and do a continuity check. So we take the pin on the IC of the floppy disk controller, move it over here, and there is no continuity. So I'm going to be using a piece of wire to bridge these two pins. So first I'm going to be applying some solder to both of the pins so that we can attach the wire more easily. And then I'm going to be taking my piece of wire, which is already tinned. I'm just going to be adding it to the two pins, effectively bridging them. Now this is a temporary fix just to verify that the floppy drive will work. I do have higher gauge wire that I will use in the final fix. And while I'm at it, I'm also going to be cleaning up the board a little bit. I'm using a variety of different tools here. I'm using vinegar, I have a toothbrush, I have a more hard brush to get most of the stuff off. I'm also using some isopropyl alcohol to do a final finish. And then, yeah, cleaned up pretty nicely. So let's put the card back in, boot the PC, and see if it will read the floppy drive now. It's still making that clicky sound, but let's see if it will boot now. So I have to press F1 to continue because the CMOS settings have been lost again. But now it is able to boot off the floppy disk. So yeah, this seems to be a good fix here. You can ignore the errors here because this is a boot disk that expects to find something on a hard drive. But now, moving to our memory card, which contains an additional 128 kilobytes of RAM, bumping up the total memory to 640 kilobytes. And as you can see, the battery has also leaked on this card. Hopefully it is only some superficial damage here. So there are some pins located in this area, but I don't think any of the traces have been impacted. But also on the back, this seems to be pretty clean. So it's just the edge of the expansion card that has been impacted. Again, the expansion brackets took most of the hit here. So I'm going to be using some vinegar to loosen up the crud here on the card, both on the front and on the back. And then we should be able to clean this up pretty nicely. I'm just going to be using a piece of paper here to get most of the stuff off. So applying some vinegar again and brushing everything off and getting everything nice and clean. Same goes for the front, so I'm just going to be applying some vinegar here and then brushing everything off. So I'm pretty happy with the end result, except for the fact that I did remove part of the silk screen here. Now the memory expansion card has 18 memory chips installed, 2 of which are used for parity, so we have 2 banks of 8 chips. So every chip contains 8 kilobytes of RAM, bringing a total of 128 kilobytes of RAM on this card. But let's put the card back in and see if it will detect the additional memory. So for that we need to go into the GSetup program and configure the base memory size to 640 kilobytes, exit the program, reboot the PC, and then see if it will work. Because if you fail to configure the exact amount of memory using GSetup, you will get an error on startup saying that the system options aren't set correctly. So in this case we're not getting an error, which is already a good thing. It did do the memory test to 640 kilobytes, and now if we go into MS-DOS and we execute the mem command, we should see the full 640 kilobytes of memory available in this machine. And here it is. Now the final card I want to talk about today is this serial parallel card from IBM. So this features a serial and parallel connector, and it is also heavily impacted. So both the bracket and the connectors on the card have all kinds of battery gunk on them. The rest of the card seems to be okay, but man, this is, yeah, I'm not really sure if it's worthwhile saving this. I am going to give it a try because this is an IBM card, and this is the card that originally came with the IBM AT5170. So it is worthwhile to take a look at it, but I doubt that we will be able to reuse these connectors. So I think first we need to make sure that we can do as much cleaning as possible in order to be able to free up these connectors so that we are able to remove them from the PCB, because the way that it is right now, it will be very difficult to remove the screws and to desolder these connectors. So first we need to do a little bit of cleaning, and this is very tedious work. I mean, but man, I mean, this card is really far gone. Just look at this bracket here, which is basically disintegrating before our eyes. Now, obviously I could go for another 8-bit card that features a serial and parallel port, and I mean the spacing between the two connectors and the location of them is identical. I think this is pretty much standardized, so it's not going to be an issue finding a replacement bracket for this. But yeah, I still think that these connectors are just too far gone, both here internally on the PCB but also on the outside. So try to use a steel brush to get a lot of the crud away here, because in order to remove the bracket and free up the connectors, you need to be able to remove the screws which are in here, which are totally bolted down. I mean, these things just wouldn't move an inch, and at one point one just snapped off as I was trying to release it, and it got stuck in my tool here. And at that point I was pretty much fed up with it, so I used some brute force to remove the bracket, and ultimately the screw just came out with brute force. The thing is that I will probably need to desolder these connectors and find new connectors that have the same form factor, because there are mounting holes on the PCB that need to correspond. So I'm not really sure if I will be able to find those, but yeah, this is the current state of the card. If anybody has any ideas or suggestions or comments on how one should approach a restoration or cleanup of a card which is so far gone, please let me know in the comments. I'd be very interested in hearing about that. But I am glad that we got the machine up and running again, that the hard drive works, that the floppy drive works, that we have a working system. So this is already good progress. And in the next video, I'll show you how I cleaned up all of the external parts, like the case and the front panel, the case itself, which was very rusty. I'm also going to take a look at the brackets of all the expansion cards and see which ones we can still save. Basically, all we need to do in order to reach our end goal and getting her to look like this. So I hope you guys will stick around for that. I think there's going to be one more part in this series and then it should be final. So please stick around, hit that subscribe button, hit the notification bell. Please give me your feedback in the comment section below. And I really hope to see you guys soon for a next video. Bye bye.